In order for us to start discussing about how we can actually have the machine do the logical reasoning that we just did, using our own brain in the Wumbus world, we need to start discussing, the interaction with the knowledge base. So the interaction of the knowledge base is kind of important, as we have coupled our ability to reason with what we store in that kind of knowledge base. So let me just write down again what is the knowledge base a bit more concretely. For us, it's going to be a set of sentences that represent rules of the world model, percepts and inferences. And we will be dealing with this, we will be treating those as kind of constraints. And this will actually become a bit more apparent the moment we kind of go back to the Wumbus world in a moment and actually look how, as we are going, as the time progresses, we start from some initial kind of set of rules. We are sort of adding more into this kind of knowledge base. And the more we add, the more constrained the world, the number of world models that we can satisfy. Okay, so we are going to just basically see that in a moment, and we will also the second thing we need to introduce here is this concept of this Venn diagram, which I'm sure you must have heard before. These are diagrams that will help us to visualize and help understand the knowledge base operations. And we will introduce and what we can get out of those operations. These are two operations we'll be discussing, the so-called ask operation and tell operation. So we ask something what the knowledge base about, and we tell the knowledge base something that we know. Okay, so let me just introduce now the operations. So we have now the tell. So we have a sentence that we want to tell the knowledge base about. So this is the knowledge base over here. And the knowledge base can return three possibilities. I knew that. This is called entailment, a bit more formally. And this is actually a very important concept. Okay, so I knew that. I don't believe that. That's a second response we can get. That is also called formally contradiction. And the third is, I can update the knowledge base with this information, and this is called formally contingency. Okay, so this is the first operation. The second is the so-called ask operation. So we want to ask about something, about this kind of sentence. Is this sentence satisfied or not? And the knowledge base will definitely respond to us in three ways. This is true. The sentence is false. And the third one is I do not know. Okay, this is a summary of these operations we will start introducing now to understand exactly all these possibilities of responses we get out of the knowledge base. Let's start with the tell operation and responses. Okay, so the first one I want to cover is, I do not know that. And this is what we call formally the entailment. And it will use the symbol, like this symbol is used for entailment. And it's looks like a kind of hammer. Okay, all right, so, and the corresponding kind of Venn diagram, which I will explain now, is looks like this. So as we said earlier, in another video, we had these models of that satisfy the sentence A1, let's say, and we have another set of models that satisfy the sentence A2. And when we have already in the knowledge base, let's say the sentence A1, and we are the knowledge base contains A1 and the two sentences A2. Okay, and so the this intersection over here is what we let's call it this intersection of the models of the sentences, generally I sentences that we have in the knowledge base, is the set of models that satisfy the knowledge base. So the intersection comes from the fact that the set of models that satisfy the knowledge base is the set of models satisfy A1 and the set of models satisfy A2 at the same time. Therefore, that's where the intersection comes in. And this goes back to what I said earlier about the more sentences we have, the potentially for more constraints that we will face. So this area, the more sentences we add in the knowledge base, will actually start shrinking. Okay, so when A1 was alone, then in the knowledge base, then the set of models for the sentence A1 was this, but when another sentence came in, then the set of models that satisfy the knowledge base are shrunk, and this is it. So this area over here is the set of models for that knowledge base for knowledge base. So let's assume now that this is the knowledge base and another sentence A3 is coming in. Okay, so, and we will tell, in other words, the knowledge base about A3. Okay, so we are have this situation right now, and if when we have entailment, then the set of models for A3 will actually look like this. Will be a superset of the set of models already that satisfy the knowledge base. So we are writing that if, and I'll explain that why, if the set of models of the knowledge base and the intersection of the set of models of A3 does not change the set of models that are satisfied by the knowledge base, then the response will be, I know that, and therefore we will write the knowledge base entails A3. So A3 can be logically concluded from what we already know in the knowledge base. So a couple of examples over here. Let's assume simplistically that the knowledge base contains the sentence A that, let's say, x is equal to 0. Okay, and another sentence comes in that xy is equal to 0. Then we can entail beta from A. Obviously, no matter what the value of y is, then we will actually have the response will be, okay, so this sentence is actually coming in. Already I know that this sentence is actually true, and from just knowing A. All right, so that's basically one example. The other example we actually have here is that, let's say that we have a sentence A, 1, which is rain, R for rain, let's say. And we have another sentence in the knowledge base. So let me write it down here as this is the knowledge base at this moment, and this is the snow. So that is the knowledge base. And what we actually have here, we have a sentence. Let me write it down also over here that the tail operation is coming. All right, so this is the sentence A3. And what we can actually conclude here in this A3 sentence, the A3 sentence, is rain or snow. Definitely we can write that the knowledge base implies A3, or logical, the A3 is logically concluded from that knowledge base that we have here, because evidently if we already know that rain is true and snow is true, then evidently the or relationship over here will also be true, and that's an explanation of entailment whenever we have entailment. So let's look at I don't agree with that. The so-called contradiction. So in the contradiction, the Venn diagrams are actually quite simple. So we have a set of models, let's say for the sentence A1. And there is, in fact, the set of models for the knowledge base that satisfy the knowledge base. We have a knowledge base with some sentences inside. And we have a sentence coming in, let's say A3. And as you can actually see here, we have no common ground on how the world works. What I have sensed or inferred. And this is basically when we have a contradiction. Absolutely no intersection between what we already know as true and perceived either perception information or axioms that the world model, how the actions of the world model, or other inference we have done. Another sentence is actually coming in as A3, and then the knowledge-based response, I'm not agreeing with that because that contradicts everything that I know up to this point. Okay, and the third one is, I will update the database or the knowledge base. And this is actually called contingency. Okay, so this is, in this case, we have another Venn diagram. So we have here the set of models that satisfy the knowledge base. And when the sentence comes in, there is an intersection So let's try to understand that part, which is the part where we actually can grow the database. We can actually write here as, from one side we have the set of models that satisfy the knowledge base intersecting with a set of models that satisfy the A3. That intersection is a strict subset of the set of models that satisfy the knowledge base on one hand. And also that strict subset is not null. So the null set is a strict subset of the set of models that satisfy the knowledge base. And actually we can interpret this as follows, that the sentence A3 reduced the set of models that satisfy the knowledge base and this reduction is effectively the synonym of adding more information to the knowledge base. And so we actually can write that the following, and also this is the explanation for this part, and the explanation for that part over here is that what I know does not contradict alpha 3. And we saw the contradiction here, that the intersection between the knowledge base and the alpha 3 was null in this case. And in that case, evidently this is this intersection over here is not going to be 0, and that is basically the two sort of explanations of this formula. So let's try to provide a couple of examples here. Just one example, in fact. So in the Wumbus world, we saw that the knowledge base is at some point has this kind of negation that there is no breeze in location 1, 1. And suddenly the sentence A3 comes in, and the sentence A3 says that there is a breeze in 2, 1. And if you go back to the Wumbus world video, then you actually can see that this is the case for the word that we have already specified. So there was a rule that there is no pit, and there is absolutely also no sensing that we can detect for in this specific cell. And in fact, there is a breeze in 2, 1. And for these two sort of rules or sentences, we have the arrival of A3 definitely adds information to the knowledge base, and we will list it as such as an additional kind of rule. And now if we look at the so-called ask operation responses, now that we have introduced entailment, it's actually pretty clear. So we have a knowledge base that we are asking something about the sentence A. And we said that we have 3 responses. The one is true. And this response actually will come every time that we are able to entail A or alpha from the knowledge base. We will definitely respond with false every time we are not able to do that. Therefore, we are able to entail the negation of A. And then finally, we can respond that I do not know. Which means that we cannot entail either the positive or the negative of the sentence.